0.07 inches is the depth of soil lost annually since Europeans set foot in North America. In just 30 years, the United States may have only 5% of its land left intact. One can notice how erosion strips the fertile layers from the fields. This degradation pushes a global superpower to the brink of resource exhaustion. But this is just the beginning. Modern science continues to struggle for a solution. At first glance, the remedy seems impossible, but the answer emerged from an idea once considered the most outrageous in conservation history. Bringing bison back to dying lands offered a new hope. This strategy targeted the very structure of the soil. How did this giant species, once nearly extinct, ignite a remarkable ecological revolution? The biological mechanism works differently than machines. In just 10 years, they transformed barren ground into thriving grasslands. It gets more complex further on. Their heavy movement reshapes the terrain physically. Thus, they became the greatest engineers of the North American prairie. 60 million animals moved like black rivers across the green expanse, forming the beating heart of a colossal ecosystem. Why did the North American prairie collapse so catastrophically after thriving for millennia? To the untrained eye, it looks like the result of simple agricultural expansion. But in reality, the removal of the bison destroyed the complex biological engine that sustained the soil itself. This vast territory, known to scientists as the Great Bison Belt, stretched all the way from Canada to Texas. But when Europeans arrived in the 16th century, the ecosystem began to spiral downward. The population collapsed from 60 million down to a mere 325 survivors in less than 100 years. Behind this frenzy lay not just the profit from hides and meat, but a silent strategic goal to weaken indigenous livelihoods by clearing the path for settlement. But this is just the beginning of the tragedy. One can notice how the remaining prairie was carved apart by heavy plows, farms, and domestic cattle herds. At first glance, replacing wild herds with livestock seems like a logical swap. But in reality, the soil became compacted, causing native grasses to wither and die. The delicate microbial systems beneath the ground were shattered completely. Everything only gets more complicated from here. Winds lifted hundreds of millions of tons of topsoil into the air during the Dust Bowl of the 1930s. That devastation forced the world to recognize a critical truth as dust clouds drifted over the Atlantic Ocean. The prairie landscape creates a complex dependency on the very animal that shaped it. $10 million. That was the sum-risking loss in the early 21st century during a daring experiment. When standard solutions failed, ecologists proposed returning to pre-human natural operations. They bet on changing the grazers, not the soil. Reintroducing bison to dead lands seemed absurd, but this is just the beginning. Trucks released the animals onto dry, cracked ground where grass no longer existed. Why release them into such a hostile environment? Predictions screamed that the bison would not survive long without fodder. But the truth turned out to be completely different once the heavy hooves hit the earth. At first glance, the release was a milestone, but in reality, the herd vanished instantly. One can notice how researchers scrambled drones and helicopters to locate the animals. GPS signals failed, and fears mounted that the bison had died or escaped the zone. It gets more complex further on. It is visible from subsequent data that they moved toward higher ground, devoid of vegetation. No one understood this behavior, placing the project on the brink of collapse. 250 scientists faced unemployment as the ambitious restoration effort faltered. The situation remained tense as the search continued without immediate results. Tens of thousands of years of evolution have refined the survival instinct of the bison, distinguishing them from puzzle solvers like dolphins or crows. When living in a safe environment, these animals reveal a completely different side, appearing curious and observant like a child discovering the world for the first time. One can notice a bison calf learning to swim from its earliest days, with the mother always positioning herself directly behind it, ready to plunge into the cold water if danger appears. This blend of courage, persistence, and herd protection makes them perfect ecological engineers, even if they never intended to play such a role. But this is just the beginning. Why did their sudden disappearance from view signal a positive environmental shift? At first glance, it seemed they had simply vanished. But in reality, this absence meant they had begun doing what they do best, restoring the land through constant activity. Unlike cattle, which tend to stand in one place and compact the soil into hardened patches, bison move constantly across the prairie. They almost never stay too long at a single point, preventing the degradation of the terrain. Each step of their heavy hooves loosens the topsoil, mechanically opening tiny channels in the ground. These fractures allow rainwater to soak deep into the earth instead of running off the surface. It gets more complex further on. One can notice that every pile of dung scattered along their path becomes a natural source of nutrients. These deposits are rich in nitrogen, phosphorus, and potassium, elements that native grasses have critically lacked for decades. Furthermore, the nearly 1-ton body of a bison creates shallow depressions when rolling, forming structures that function as natural water collectors. These pits retain moisture, letting it seep slowly into the ground rather than washing away. The rolling action also removes old, dead vegetation, exposing bare patches of earth. And this is not the limit. Seeds caught in their thick fur fall into these micro-nurseries, finding the perfect conditions to germinate. Most importantly, the herd is always moving, which guarantees they never overgraze an area. This leaves behind patches of land with enough time to recover and regenerate. 3 years passed before small green patches quietly broke through the crust of what was once considered hopeless land. By the 4th year, native grasses returned in force, covering the dry earth. By the 10th year, surveillance drones recorded a scene no one believed possible as a near-dead desert transformed into a vibrant grassland full of color. But this is just the beginning. The return of dense vegetation inevitably brought back the wildlife that depends on it for survival. Bird species that had been absent for 20 to 30 years began to nest in the tall grass again. Pollinating insects reappeared along with many small mammals, drawing in predators like foxes, coyotes, and bobcats to reestablish themselves in the area. One can notice how streams that once dried up in summer now held water much longer due to the soil retaining moisture. Why cannot other large grazers simply replace the bison in this chain? It would seem that any herd animal could maintain the biological balance. However, the ecosystem restores itself according to thousands of years of evolution only with this specific species. Findings from the Kansas-Kansa Prairie show that in areas with bison, plant species richness increased by up to 86% over more than 3 decades. Meanwhile, areas grazed only by cattle increased by around 30%, and places without grazers were the least diverse of all. It gets more complex further on. At first glance, cattle and bison appear to play a similar role, but in reality, their impact on the land is fundamentally different. Even cattle cannot create the same impact because they stand in one place for too long, compacting the soil, breaking its structure, and causing severe erosion. Regions where bison have been reintroduced are now expanding their borders. Tallgrass Prairie. Preserve in Oklahoma, once a cattle ranch, has become the largest restored tallgrass prairie in the world. Its herd has grown from 300 bison to nearly 2,000 heads. In Montana, the American Prairie Project aims to create a wild reserve. Thus, the natural cycle returns to its original rhythm. 3.2 million acres is the total target area for a massive wildlife corridor designed to house around 10,000 bison. In Mexico, where the species had completely vanished in the 19th century, a herd reintroduced from just 23 individuals in 2009 has expanded to over 200 today. One can observe how this population growth is actively reviving the entire Janos grassland ecosystem. Even in regions like Illinois, abandoned industrial zones have been transformed into prairies thanks to the return of the herds. But this is just the beginning. In reality, one cannot simply release bison onto the land and wait for a miracle. Managers in Oklahoma actively burn 1/3 of the reserve every single year to mimic natural conditions. Why is such a drastic measure necessary for restoration? It seems counterintuitive to burn the ecosystem one aims to protect. But without this intervention, the land lacks fire, which was an essential component of prairies for thousands of years. One can notice how the flames remove layers of dead vegetation to clear the soil surface. At first glance, the scorched earth looks like damage, but in reality, this process triggers the strong regrowth of young grasses, creating ideal food sources. When bison and fire operate together under this ancient ecological pattern, the prairie revives more powerfully than with any artificial method. It does not end at this stage. Data collected after 10 years of reintroduction reveals a significant shift in the physical parameters of the soil. Moisture levels increase by 25 to 40% after rainfall events, retaining water deep in the ground. It is visible how erosion decreases by nearly half, while plant species richness rises by 70 to 80% depending on the region. Areas that once lost all vegetation turn into dense biodiversity hotspots. Remarkably, no technology, irrigation system, or artificial fertilizer was behind this transformation. Only the presence of bison and the natural environment. Thousands of years mark the natural processes these animals have followed. One can notice how their movements shape the terrain. But this is just the beginning. What would happen if millions of bison were allowed to return across North America? The return of such populations implies a massive shift. The Great Plains could regain their historic form. Soil erosion, land degradation, and even climate change reduced simply by letting nature do its job. At first glance, this seems passive, but in reality, bison have accomplished what humans failed to do in hundreds of years of soil management. It is visible how they transformed a dead landscape into a living ecosystem. The biological balance resets. Thus, ecological restoration comes not from expensive technologies, but from understanding how natural systems work. One can see how this effectively restores the environment. The process continues its natural rhythm. 95% constitutes the overwhelming majority of modern bison existing solely as commercial products within the meat industry. Only 5% remain as true ecological engineers, the solitary individuals still capable of physically reviving an entire prairie. The bison meat sector is now valued at over $350 million annually in the United States alone. Demand for this high-protein, low-cholesterol superfood rises steadily by 10 to 15% each year. But this is just the beginning. This economic value has pushed most bison into industrial farming, unintentionally shrinking the chances for the species to recover naturally. Why is the distinction between industrial livestock and wild ecological engineers so critical? One can observe that both industrial and wild animals look identical as they graze in the open fields. But without the freedom to roam, the animals cannot execute the ancient migration routes required to maintain the ecosystem's balance. At first glance, a bison rolling its massive weight in the dust seems like a simple action, but in reality, it is a calculated mechanism for soil aeration. One can notice how their sharp hooves break the hard earth, while dung provides essential nutrients to the roots. These physical interactions once kept an entire continent functioning. When they disappeared, the prairie collapsed. Now, it is visible how the landscape begins to live again the moment they return. It gets more complex further on. The revival they produced after 10 years astonished scientists monitoring the ecological data. Yet for nature, perhaps that is simply how things were always meant to be structured. The story of the bison is not just about the recovery of a single species, but a reminder that continental prosperity depends on the simplest links in the chain. Systems work by restoring the missing pieces to their functional positions. In their return, it becomes clear that the most powerful solutions to modern crises are the ones written into the land long before we arrived. And the final question for all of us is simple. If one bison herd can save a dying landscape, do we have the courage to let millions do the same?